Good evening, everyone. Can you hear me? Can somebody please confirm? You can hear. Yeah, thank you. So, good evening, everyone. I'm Shankar Rao, PhD scholar in Department of Electrical Engineering, IIT Hyderabad. So, today, in today's session, what we will do is like we will take some problems, some previous year questions, gate questions from digital electronics, and we'll solve those problems by like covering relevant concepts and all. And if time permits, we will also solve few problems from network engineering. Okay. So, this is the first problem. This question was given in GATE 2016 ECE in set 1 for 1 mark. So the digital circuits is given with A, B, C as inputs and Y as output. So we are asked to find out so what is the output of this circuit. So MCQ question. And here we have like two different types of gates are there. One is AND gate and AND gate, NAND gate, AND gate and XOR gate. So let us say we'll solve directly. I think already you know all these things. So let us say the output of this AND gate is P, and here output of this XOR gate is Q, and let us say output of this AND gate. Yeah, fine. Now, what is the output of first AND gate? Let us say this is first AND gate. Its output is AB. So its output is AB, and output of second AND gate is BC. So this we already know. Suppose we have an AND gate, and let us say A and B are the inputs. Then output is A and B. Okay. The truth table also, you know. So for all possible inputs, when both A and B are 1, then only the output is 1. In rest of the cases, the output is 0. This already you know. And another gate we have is XOR gate. So this is the XOR gate we have. Let us say A and B are the inputs of XOR gate. So you know what is the output of XOR gate is A XOR B. So that is A B bar. XOR operation is A B bar plus A bar B. Think the truth table you already know. Let us say A B are the inputs, Y is the output. Then 0 0 0 1 1 0 and 1 1. So when both are zeros or both are ones, the output is 0. And when the inputs are different, then the output is 1. These things you already know. So now from here, the output of first AND gate is AB, and output of second AND gate is BC. Now output of third AND gate is what? So here AB is the input, one input is AB and the second input is C. The output of third AND gate, that is nothing but P. P equal to what? A, B, C. Okay. And what about Q? For the, let us say, gate 4. Gate 4 is XOR gate. So for gate 4, one input is BC and another input is AB. So what is Q? So I am writing here. So Y is, the final output Y is P XOR Q, right? P XOR Q. So that is P bar Q plus PQ bar, and output of fourth gate, that is Q, is AB XOR BC. This also we can write B, we can take common, A XOR C. Okay. And what is P? Output of third gate, that already we have seen, that is A, B, C. So output of third gate is A, B, C. So what we get now, Y is, our Y is P bar Q plus PQ bar. So P bar is A, B, C whole bar into Q is, we can say B into A XOR C plus P Q bar. A, B, C into Q bar is B into A XOR C whole bar. Okay. So what we have done is just P and Q we found out and we replaced in Y. Now this I can write like A bar plus B bar plus C bar. We know the De Morgan's law. If we have like A plus B plus C, let us say whole bar, then we can write this as A bar dot B bar dot C bar. This is De Morgan's first law or second law something, and we have like A B C whole bar whole complement, then this we can write like A bar plus B bar plus C bar. So from these two, the first one will become, the first term will become A bar B bar C bar, this one using the De Morgan's law, into B into A XOR C is A bar C plus AC bar. Okay, and the second term will become A B C into, I can write like B bar plus A XOR C whole bar. Now in the first one, see B and B bar if you multiply will get 0. So B and B bar if you multiply will get 0, and what we left with is in the first one, from the first one. So B and B bar, we know the sum x into x bar is 0. So that term will become 0. Then what is left is A bar plus C bar into B into A bar C plus AC bar. And here what we get is B into, and we can take distribution law we can use. So what we get is A bar C plus, here the next term is A bar A C bar plus A bar C C bar plus A C bar into C bar. So if we see here, this will become 0 because A bar is there. This also becomes 0. C bar is there. And the first one, so what we are left with is B into A bar C plus, here we will have A C bar. Okay, this is from the first one. And from the second one, so this one, the second one I'm writing here, that is A B C into B bar plus A bar A XOR C whole bar, that is nothing but A XOR C, we know when there are two inputs. So this if I write, so what I get is A bar C bar plus AC I will get. Now you multiply these two. Here what we get is A B C into B bar plus A B C into A bar C bar plus A B C into AC. Here B bar is there, so it will become 0, and here A bar A is there, so it becomes 0, and this will become A B C. because we know x into x will get x and x will get x only. Here ABC and AC, so we'll get ABC only. So what we got here is this one we got B into from the first term A bar C plus AC bar, and from the second term what we got is ABC, right? Now further we need to simplify this. So this is A bar BC plus ABC bar plus ABC. I'm just expanding. Okay. Now from these two AB I can take common. AB into C bar plus C. So we know some x plus x bar, x or x bar is 1. This we know. So this is 1. Now what we are left with is A bar BC plus AB. So from here we can take B common, then what we get is A plus A bar C, but that is not there in the options. So options that is not there, still we need to simplify this, and we know the distribution law. So we know something like x into y plus z. This we know x and y plus z is x y plus xz. This is distributive law. If we take dual of this, I think that also you know. So x plus yz, we know dual means in an expression all and or operation should be replaced, interchanged, and zeros and ones are interchanged. Okay, so that is dual. So this law very well we know. If we apply dual for that, instead of and we replace r, instead of r we replace n. Then what we get is x plus y and x plus z. The same law we can apply here. So from that what we get b into a plus c into a plus a bar. So this a plus a bar is 1. So what we get is b into a plus c. So this is the answer. So if you see this, c is the option, b into c plus c. So I did in this way. So you can, instead of this in the exam, you can take assume some values for a and b and c. One set of values you can assume, and you can find out, you can check from the options. You assume values a and b c such that like we will get different answers from the options. Okay, in that way also you can solve this. Is this okay? Somebody has. Okay, I think these things already you know. So fine. If you don't have any questions, then we can move on to the next question. Okay, thank you. Yeah, the next question. This was given in GATE 2015 ECE set 2 for 1 mark. The question is, in the figure shown, the output Y is required to be, this is the output that we want. The gates G1, G2 must be respectively. So options are given. So just you have a look and please let me know like the answer, like what will be the combinations for G1 and G2. Just a simple question only. So can you please like answer me like what are the options for G1 and G2? So in this we want y as ab plus c bar d bar we want y. So here, so G1 and G2 we don't know. That is okay. Now let us say C and D. What is the output of this gate? This is which gate? This is NOR gate, right? What is the output of NOR gate? This is C plus D whole bar, right? This also we can write like C bar D bar using De Morgan's law. We have discussed it, right? Just then. So x plus y plus z whole complement is x complement and y complement and z complement, right? So the output of this NOR gate is C bar D bar. So see here, y output we want, we have the term C bar D bar is also there. So, and you see here, we need the output this one. Already we have one term C bar D bar is input for G2. Then what should be gate G2? It should be some kind of OR gate, right? OR gate, right? It should be OR gate, then only this term as it is will go. And here we have some plus operation, so OR operation. So G2 is an OR gate, fine. Now what should be the input of G2? If it is OR gate, so if it is OR gate, this is G2, let us say. One input is C bar D bar already there. So we want output AB plus C bar D bar. Then what should be the other input? The other input should be AB, right? If the other input is AB, then only we'll get output AB plus C bar D bar, right? So that means this should be AB. Okay. Now to get AB as output of gate G1, what is that gate? What should be the gate? So because input of gate G1 is A bar and B bar. After A and B there are inverters, so A bar and B bar. So we need to get output of gate G1 as AB. Then how we will get? If it is a NOR gate, let us say, if G1 is NOR gate, so here we have A bar, here we have B bar, then what we get? A bar plus B bar whole bar. So this is A bar into B bar whole bar, this is AB, right? So that means if G1 is NOR gate, if G1 is NOR gate, output of G1 is AB will get, right? Output of G1 AB will get. And if G2 is OR gate and G2 inputs are AB and C bar D bar is there, if G2 is OR gate, then we'll get the output AB plus C bar D bar. So the options for G1 and G2 are NOR and OR. This is the option. Okay. NOR and OR are the options. Is that okay? So let me repeat. We want output as AB plus C bar D bar, because the lower gate, that is this, here we have NOR gate, its output already we found out, that is C bar D bar, right? The C bar D bar as it is should go to the output, and also there is output, there is some plus here. Suppose if you take G2 as OR gate, and here if input of one input of GB, if G2 is, if it is AB, the other input anyway C bar D bar is there, then required output you will get. So G2 is OR gate. Now if G1, if I take some NOR gate, Then what is the output of G1? So A bar plus B bar whole bar, that is AB. If this is NOR gate, then we'll get output here A bar plus B bar whole bar AB, right? Then the required output will get. Is that okay? Any doubts, or can we move to the next question? Yeah, thank you. This is the another question. This was given in GATE 2017, ECE set 1 for 2 marks. The question is, which one of the following gives the simplified sum of products expression? We want SOP form, simplified SOP form for the Boolean function, where M0, M2, M3, M5 are the minterms corresponds to the A, B and C, and A is the MSB and C is the LSB. Okay, so this we can solve using K-map simplification, or we can simply use some Boolean functions to solve this. So here some we can see some term called minterms. I hope you know minterms. So let me just explain about minterms. Okay. Now let us say we have some function f of a, b, c. Okay. We have some function f of a, b, c. Suppose if I consider product terms. Okay. If I consider product terms, which will have all the variables. So here what are the variables? A, B, C. We have 3 variables are there. If we consider all the variables A, B, C, okay, and if we consider product terms which will have variables either in the form of variable or in the form of variable complement, then they are called standard product terms. Standard product terms or min terms. Okay, hope you have understood. So they should have all the variables. They should not miss any of the variables, either in variable form or complement form. Then they are called minterms. Let us say here 3 variables A, B, C are there. Then I am taking something like this. This is a minterm. Okay, and something like this. This is a minterm. Or A, B, C. This is a minterm. Or A bar, B bar, C bar. This is a minterm. Okay, suppose if you take A bar B, this is not a min term, this is a product term. This is a product term but not standard product term or min term. If it is min term means it should have all the variables. Here C is missing, so it's not a min term. Okay, suppose a function is having n variables, a function is having n variables, then it will have 2 power n min terms. It will have, a function is having n variables, then it will have 2 power n min terms. Since here we have 3 variables, so we will have 2 cube variables. We will have, sorry, 2 cube min terms. We will have here 8 min terms we will have. Okay, and also in min term representation, suppose let us say we have some variable, then it we represent with 1, and a variable complement we represent with 0. Okay, and we can also give names to those minterms. So we have, I'm just writing out all the minterms here. So we have three variables, two cube, eight combinations will get, eight minterms will get. So I'm just writing here a bar, b bar, c bar, a bar, b bar, c, a bar, b, c bar. All combinations I'm just writing out. That's it. A bar, b, c, a, b bar, c bar, and a, b bar, c, and a, b, c bar, and a, b, c. These are the all possible eight minterms. As I said, a minterm in minterms representation, a variable is given weight 0 and variable complement is given weight variable as weight 0, weight 1, and variable complement will give weight 0. So here the weights are a bar is 0, I'm just writing out here, b bar is 0, and c bar is 0. Similarly here a bar is 0, b bar is 0, c is 1, like that. 0 1 0, a bar is 0, b is 1, c is 1, a is 1, b bar is 0, c bar is 0, a is 1, b bar 0, c 1. Here 1 1 0 1 1 1. Now minterms will represent with small m. So minterms will represent with small m. So I am also giving some number, some representation for these minterms. So small m with suffix, what is the weight you see here? 0 0 0, a bar, b bar, c bar. So a bar is 0, b bar is 0, c bar is 0. So weight here is 0, so suffix you give minterm 0. Okay, similarly the second minterm is a bar, b bar, c. So 0 0 1, 0 0 1 means what is the decimal equivalent? 1. So this is m1. Similarly, third one is a bar, b, c bar. So its decimal equivalent is 2. So like that m2, its equivalent is m3, m4, m5, m6, m7. Okay, these are minterms. Hope you know these things. Just revising. Okay, and there are some properties of minterms. Sum of all minterms will become 1. Suppose you have here 8 minterms. Let us say j equal to 0 to 7. All minterms I'm taking here. Sum of all minterms will become 1. Okay, this is about minterms. So in the same context I'll also talk about max terms. For this problem max terms is not required, but still I'm talking about max terms. Suppose if a function of n variables, let us say n variables, then we will have 2 power n max terms we'll have. Okay, so what are max terms? We'll see. We know product sum terms. Okay, suppose a sum term, if you take of these variables, if it is having all the variables either in the complement form or variable form, then they are called standard sum terms. This is a sum term. Standard sum term means it should have all the variables, three variables a, b, c, either in like that in the same form or in the complement form, then they are called max terms. So this is a max term, or a bar plus b plus c bar, this is max term. Okay, so standard sum terms are also called max terms. Okay, so the max terms are represented with capital M. Okay, in max term representation a variable is there, it is given weight 0 and variable complement weight given 1. In min terms, if you see, variable is given weight 1 and variable complement given 0, but max terms just opposite to that, variable 0 and variable complement 1 we will give. So I said three variables we have, so 2 power 3, 8 max terms will get like min terms only, they're equal. So 2 power 3, 8 max terms will get. What are the max terms also? I'll write all combinations. So I'm just writing out here all combinations. A plus b plus c whole bar, a plus b plus C. Okay, A plus B plus C. I said if a variable is there, we'll give 0, and variable complement is there, we'll give 1. So for here, for A bar 1, B bar 1, C bar 1. So this is 1, 1, 1. Okay, its decimal equivalent is 7. So that's why max terms are represented with M. So this max term is called M7. Okay, now here A bar plus B bar plus C bar, A bar is 1, B bar is 1, C is 0. So this is 6. So that's why this is M6. Similarly, this is M5. So 101 M5. So this is 100 M4. This is 011 M3. This is 010 M2. This is 001 M1. This is 000 M0. These are max terms. So, and also there is one property, sum of all max terms, product of all max terms A equal to 1 to 7, all max terms is 0. Sum of all minterms is 1 and product of all max terms is 0. And another property we can, the relation between minterms and max term is, let us say I am taking some minterm, small m5 I am taking minterm. So that means this is what? A, B, C, m5, right? So this is m5. Suppose if I am taking minterm complement, then what will happen? We'll see A, B bar, C whole bar. So this is A bar plus B plus C bar according to De Morgan's law. So this is what? 101. This is the max term, right? So max term M5. That means max term complement equal to min term. Any max term complement is min term and vice versa. Some min term complement is max term. So these are about min terms and max terms. So now we will go to the problem. And one more thing is here in min terms and max terms while writing. So here f of a, b, c. Here while giving the numbering to the min terms and max terms. So what I did here, I took a as MSB, most significant bit, and c as least significant bit. Okay. So a is here most significant bit and C is here least significant bit, right? Based on that only we have given weights, right? So if you see in this one M6, A, B, C 110, A is most significant bit, that's why it is given weight 2 square. B is 2 power 1, C is least significant bit 2 power 0 weight I have given. Okay, is that okay? Any doubts in this, or else we'll directly go to the problem. Fine. In the question it is given m0 plus m2 plus m3 plus m5. So f is m0. What is m0 here? So we have, and here given A as MSB they have given, C as LSB they have given. So m0 is A, B, C, A bar, B bar, C bar. And what is m2? M2 is A bar, B, C bar. And what is m3? A bar, B, C. And what is M5? A, B bar, C. Okay. So only they have given in terms of min terms. So we can express in terms of A, B, C. Because they have given function is inputs A, B, C. For the function inputs A, B, C. That means f of A, B, C they have given in the problem. Now this you can solve using some Boolean laws, or else we can solve using K-map. You know well, I guess, K-map simplification. Okay, so this you can solve using Boolean laws, because we know we have expressed in terms of ABC, or else we can solve using K-map simplification. Right? Hope you know about K-map simplification. Let us say, I'll write here only. So to simplify a n variable function, we require n variable K-map. Since here the function is having three variables, so we require a three variable K-map. I'm just directly drawing the K-map here. So three variables means 2 cube, 8 minterms will be there. So in the K-map we should have 8 cells. Hope you know this, 8 cells. So variables are A and B, C. A is MSB and C is LSB. So you know how to form a K-map. 0 1 for BC 0 0 0 1. We write gray code instead of binary code here. Gray code, that's why 0 0 0 1 1 1 1 0. So that means here 0 means A bar and 1 is A. Here this is B bar, C bar. This is in terms of min terms we are considering this K map, B bar C, BC and BC bar. Now what is the, for each cell we will give some numbering, right? So if we give numbering for the first cell, what is that? From here you see first cell corresponds to what? The first cell, just redrawing it, yeah. The first cell corresponds to what? See here, A bar and BC. The first cell corresponds to A bar BC. So A bar is 0, B bar C bar 0 0. That means this is min term 0. 0 0 means min term 0, that you know. So this is min term 0. I think the numbering also you know. Sorry. So this is min term 0. Similarly, this is min term 1, this is min term 2, this is min term 3. Okay, and this is min term 4, 5, this is 6 and 7. Now how to solve this? So what are the min terms present in the function? In those cells we'll keep 1 and other cells we keep 0. So what are the min terms present? Min term 0 is there, 2 is there, 3 is there, 5 is there. So min term 0 is there, I'm keeping 1. Min term 0 is there, I'm keeping 1. 2 is there, I'm keeping 1. 3 is there, I'm keeping 1. And 5 is there, I'm keeping 1. And remaining all zeros. Okay. Now next is what, once you have placed the min terms in the each cell, then next thing is the mapping. Hope you know this. So you know how to group them. First we'll check for the octet. If octet is not there, then we'll check for quad, and if it is not there we'll check for pair. What is octet, you know, right? Group of 8 adjacent minterms is called octet, and quad is group of 4 adjacent minterms. Here octet is not there, quad also not there, but we can have pair. So these two we can group pair, and also we can group this one and this one, another pair. So this is one implicant, prime implicant. This is another pair, another prime implicant. I'm assuming that you know K maps well. That's what I'm little bit not touching all the details. And this one we cannot group with anyone, so we will take this as it is. Okay. Now for the first prime implicant, what we will get here for the first prime implicant? this one, right? So along the A side, along this direction, what is common? Hope that you know A bar, and along the other direction, what is common? Along this direction, I mean this direction. Okay, I'm just writing it green. Along this direction, the common is B is common, right? So the corresponding literal I'm writing here. So this direction A bar is common for both of this, and this direction B is common. Similarly, for the second one, second prime implicant, this one, again along this direction A bar is common for both of them, and along the other direction what is common? C bar is common. Here C bar is there, here C bar is there. Okay, and now for third one, as it is we can directly write here, because we are not grouping, we are not simplifying it. So this is A, B bar, C. Okay, now the simplified solution is, simplified expression is what? We need to add all these essential prime implicants. We'll say them essential prime implicants. I think you might have studied this. What is essential prime implicant? What is non-essential prime implicant? These things. So sum of all essential prime implicants here. So sum of all essential prime implicants. All three are here essential prime implicants only. So first one is A bar B. Second one is A bar C bar. Third one is A B bar C. Now the answer is A bar B and A bar C bar, A B bar C. Option B is the uh, right option. I hope you are well with K maps, right? Is that okay? Okay, fine. Thank you. This is another question. This was given in GATE 2022. ECE for 1 mark. This is on multiplexers. So here the question is, consider the 2-bit multiplexer is given, shown in the figure. For output to be XOR of C and D, the value for A0, A1, A2 and A3. So we have to get output as XOR of C, that is XOR of C means C and D. So XOR of C and D, output we need to get C and D. C XOR D, that is C bar D plus CD bar. Then what should be the values for A0, A1, A2 and A3? So we know about okay, fine. Let us see how to solve this. Before that, we'll try to understand about multiplexer. So you know multiplexer will have many inputs. Let us say many inputs. Input lines will say I0, I1, I2, I3. Let us say a 2 by 1 multiplexer. Okay, so 2-bit multiplexer will say, or 4 by 1 multiplexer, sorry, 2-bit multiplexer, 4 by multiplexer. That means many inputs will be there and we will have only one output. Okay, and we will have something called selection lines. Okay, now we have data coming from all the inputs and we have only one output. So based on the selection lines, that means based on the values present on the selection lines, any one of the input is selected and that will be connected to the output. So based on the selection lines, either I0 is connected to the output, or I2 is connected, or I1 is connected, or I3 is connected. any one of the outputs, sorry, any one of the input is connected to the output based on the selector lines. So let us say this selection lines I am saying S1 and S0. In selection lines also you have MSB and LSB. So here S1 is MSB and S0 is LSB. Okay. Suppose if I take an 3-bit multiplexer, let us say 3-bit multiplexer. So it will have 2 cube inputs and 1 output. Okay, it will have 2 cube inputs. The inputs are I0, I1, I2, I3, so on up to I7. 2 cube inputs are there. And only one output will be there. And the number of selection lines equal to the how many bit multiplex? It's a 3-bit one. So it will have 3 selection lines. So S0, S1 and S2. Okay. So this will say S2 is MSB and S0 is LSB. Okay. Now the output is here also, like we have seen 2-bit one, here 3-bit one. Output is what? Based on the values on the selected lines, any one of the input is connected to the output. Any one only will be connected to the output. Let us see, we'll try to understand this. Let us say we have selection lines S2 and S1 and S0, and let us say we have output. At any instant of time, one of the inputs will be collected. So let us say if all the selection lines are zeros, then I0 will be connected to the output. Output is I0. If the selection lines are 0, 0, 1, then I1 is connected. That means when the selection lines are 0, 0, 1, then I1 is connected to the output. Whatever data is present on I1, that will go to the output. That means when 0, 0, 1 is the selection lines, then output is equal to I1. Hope you got it. When 0, 1, 0 is there, then the output equal to whatever data present on the input line I2. Similarly, so when 0, 1, 1 is there, I3 is connected, 1, 0, 0 is there, I4 is connected, like this. And so on up to 1, 1, 1 is there, I7 is connected. So from this, we can express output as something like this. Let us say, same we can represent in terms of min terms, S2, S1, S0, this is MSB, this is LSB. So we can say this is M0, min term 0, min term 1, min term 2, min term 3, min term 4 up to min term 7. So how I can express output how to get the output equation in terms of inputs? I can write output as M0 into I0 plus M1 into I1 plus M2 into I2 plus so on up to M7 into I7. Okay, here M0, M1, M2 means we know M0 is S1 bar, S2 bar, S0 bar, like that. Okay, so at any instant of time, any of the min terms will be active, because any based on the, let us say, inputs I am giving S2 as 1, S0, S1 as 0, S0 as 0, then that means which min term? Min term 4. That means only min term 4 is 1, M4 is 1, and all other min terms are 0. So M4 is 1, so output is M4 is 1, this is 1, and I4. And all other min terms are 0, so what we get output is I4 will get. Okay, so this is how a multiplexer works. Now for this, let us say for this 2 by 1, just I am writing here. Okay, let us go to our problem. Let us say we have 2 by 1 multiplexer here, S1 and S0, and this is the output. Sorry, output is this one, and I0, I1, I2, I3 we have inputs. For this, now what is the output expression? M naught I naught plus M1 I1 plus M2 I2 plus M3 I3. So this S1 is, let us say, A and S0 is B. We are giving A and B as inputs at the selection lines. Then what is M0? S1 bar, S0 bar, right? So A bar, B bar into I0 plus M1 is A bar, B into I1 plus M2 is A bar, sorry, A, B bar, A, B bar into I2 plus M3 is A, B into I3. Okay, this is the equation, output equation in terms of the selection lines. Now we will go to our problem. Here, now what is the output? Can somebody tell me what is the output here? So our output is M0 into first line, that is C bar D bar into A naught, right? Here 0 or I naught are both are same, or 1 or I1, input line 1, 2 or I2, or 3 or I3, both are same. So M naught into A naught, that is C bar D bar into A naught, and M1 into A1, that is M1 means what? C bar D into A1 plus M2 C D bar into A2 plus C D into A3. This is the output here. Now what they are asking, we want the output as XOR of C and D. That means output should be something like this, C bar D plus CD bar. So we have output equation, this one. To get C bar D plus CD bar as output, that means what we want here? We want here C bar D, that means this term we want, and also CD bar, this term also if we want. That means these two terms, C bar, D bar and CD, the first and last terms we don't want. That means if I make A0 0 and A3 0, the first and last terms will become 0. And if I make A1 as 1 and A2 as 1, then what we get? C bar D plus CD bar. This is nothing but XOR of C and D. Okay, so the option is A0, A3 0 and A1, A2 are 1s, option C. So for this we should know the how to express the output of the multiplexer in terms of input and selection lines. That is very simple. So two variables one we have seen and three variables one also we have seen. The output is what? M0 into I0, M1 into I1, so on M3 into I3. M0, M1, these are min terms in terms of selection lines. That only we have written. Is that okay? Fine. If you don't have any doubts, we will move on to the next question. So this is also a similar question. This was given in GATE 2020 ECE for 1 mark and multiplexer only. You can do this. The one thing here is anyway options all are given with some like options. We don't have any zero. First thing is we need to check this kind of problems whether the multiplexer is the chip is enabled or not, the particular circuit is enabled or not. You can see here there is an enable input, and here we have a bubble and input is given 0. That means 0 bubble is like 0 bar, that is 1. 1 means high we are giving at the enable input. That means the multiplexer is enabled. Now all the operations, like whatever we have seen, the multiplexer works like that. Suppose let us say here, instead of 0 here at the enable pin, let us say we have 1. Then what is directly going to enable? What is going to enable? So 1 is there. There is a bubble, means not operation, inverting operation, 1 bar, that is 0. Low we are giving at the enable input of the chip. That means the chip is not enabled. Okay, but here anyway we don't have that problem. 0 is given, the chip is not enabled. If that kind of question is there, first we need to check whether the chip is enabled or not. Then using the same whatever we discussed, we can get the output. You can solve that one later. Fine. So that's it. Some problems from previous problems from digital electronics. So please let me know if you have any questions, or like is this okay, like how we are like conducting these classes. Like we are taking few problems. Actually we are assigned to solve some problems in the live sessions. So we are like taking those problems and trying to explain the concepts behind them, and also some other problems related to that we are taking and solving. Now is that okay for you if I solve like this, or like I think you have seen the previous classes also. We have solved from signals and the systems, like Fourier transforms, Fourier series, sampling and all we have solved. Is that okay if you do like this, or you want me to explain the concepts first, only some topic and the concepts, or else we'll take some problems, related concepts we'll brush up and we'll solve the problem. Is that okay? Okay, thank you. So in the next class, anyway, we have some more time. I think we will solve this problem. In next class, we will solve some problems from network theory. And I think maybe in next class, if time permits, we will start a DTFT. Think maybe last class, somebody has asked me to teach DTFT, discrete time Fourier transform. Next class or the next to next class, we will solve some problems from, sorry, we will first a little bit go through about DTFT and then solve some previous year gate questions from DTFT. Okay, so it's already 7, I guess. Yeah. Okay, okay, okay. Problems. So Bunty's question is take problems that are a little bit tricky. Fine. Actually, we are assigned some problems to discuss in the live sessions. We are solving them, and also other than that, we are trying to take some extra problems in the previous session. Okay, okay. Yeah, actually, digital electronics questions what were assigned for me are somewhat easier ones. Anyway, nevertheless, from next class onwards, we'll try to solve somewhat difficult and tricky problems. Okay. And any other feedback from you guys? Maybe in like one session we will do networks from some problems for networks, and after that again we'll move on to signals. Somewhat tricky problems from signals we will solve. Any other questions? Fine, then I think we will stop here. It's 7 o'clock. You have like other session about to start. So we'll stop here, and next class we will discuss some problems from, as I said, network systems, and then we'll solve some problems from, we'll touch some concepts from DTFT and the related problems. Thank you everyone for your patient listening.